Mhm. Okay. Is the screen visible?
Yes, sir.
Oh, something is happening. System is hanged. Okay. Now, shortest path. Shortest path. What is this? Let G be a simple weighted graph. Let
स्क्रीन नहीं दिख रही है.
screen is
Just
not
go.
visible. Wait.
सर
Yes.
ज्वाइन करना था किसी को.
हाँ, चयन कर दिए. Now is it visible?
Yes, sir.
Yes, sir.
Let G be a simple weighted graph. You know what is the weighted and simple graph? Okay, weighted graph. Okay, then a path of least length. A path of least length. And what is the meaning of length? Number of edge. Number of edges between two given vertices. In graph, G is called shortest path in G. Okay. Now, to find the shortest path in a weighted graph, there are several well-known procedure or algorithm to solve this problem, but we will discuss Dijkstra algorithm. Okay, Dijkstra algorithm is a algorithm in which we find the shortest path in the weighted graph. Okay, what is the Dijkstra algorithm? It is an algorithm yeah, just we can say a procedure to find a now Dijkstra algorithm. What is this? To find the shortest path, or we can say that uh, a procedure, or we can say a procedure to find the shortest path between two given vertices in a weighted graph. G is called Dijkstra algorithm. Okay, now what are the steps? What are the algorithm to find the path? So here algorithm. Now I'm writing this algorithm labels the vertices. Okay, for this, what will you do? Let G be a simple graph, simple weighted graph. It is also here that simple weighted graph. Simple weighted graph. The length of an edge from vertex, say I, say I, to a vertex, J. Say J is denoted by Dij. It is clear? The length of an edge from I to from vertex I to the vertex J is denoted by Dij. If there is no edge, if there is no edge from I, from vertex I to the vertex J, then the distance of Ij will be equal to infinite. Okay, we will take The infinite if there is no edge between I to j. Okay, if there is an edge dij, otherwise we will write the length between a I to j is infinite. Okay. Okay, now we labels the graph. Now in this algorithm we labels the vertices, we labels the vertices of the given graph, of the graph G I have, which is taken. Okay. This algorithm start by this algorithm this algorithm is assigning a permanent label O to the starting vertex, to the starting vertex, say A, and the temporary label infinite to the remaining n minus 1 vertices. At each iteration, this is nothing, it is the iteration, it is each iteration in the algorithm, another vertex get a permanent labels, get a permanent label according to the following this is the another. Okay, another vertex to the according to the following rule. What is the rule? According to the following rule. What is that rule? First, step 1. What is this? Every vertex j, every vertex J, which is not yet, which is not yet permanent, it is the permanent, labels gets a new temporary label whose value is given by value is here. What is the value? We will take the minimum old label of J, comma, old label of I plus Dij. You will take the minimum of this, and where I is the latest vertex permanently labeled in the previous iteration, and Dij is the length of the edge, is the length of the edge between vertices I and J. If I and J are not joined by an edge, then Dij will be infinite. Okay, this is the, and step 2, the smallest value among all the temporary labels is found, and this becomes the permanent label. Permanent label of the corresponding vertex. In the case of tie, select any one of the vertices for permanent labeling. Okay, and next one is
Hello, sir.
yes.
Previous slide refer.
Okay, step 1 and 2 is stated above are repeated alternately until the destination vertex, say L or B, whatever, you can take any name, B. Say B gets permanent label, gets a permanent label. Okay, this algorithm we explain this algorithm by a example. Okay, yes. This is A vertex. Suppose this is Z vertex. This is B. This is C. This is D. And this is E. Okay. And weight of this edge is 4, 2, 1, 5, 8, 10, 2, 6, 3. Okay, I have to find a shortest path between A to Z. So how you can check 1, 2, 3, 4, 5. One path is this one. 1, 2, 3. Second path. 1, 2, 3. Third path. Okay. There are lot of paths from A to B, but we have to choose that path which has the least length. Least length means number of weight of the path is least. Okay, so for this, what will you do? We will make a table from which we will find the path. Here, so here number of vertices are A, B, C, D, E and Z. There are 6 vertices and number of vertices 0, 1, 2, 3, 4. Okay, it will be a square matrix. Now, we will start from A because we are going to find the path from A to Z. From A to Z. So initial vertex is A and the distance from A to A is 0. So I can always restart from 0 and I can take the A is a permanent level. Okay. Okay. Next. And we can see that from A to A is distance 0 and from others the distance will be hello. Are you getting my point?
Yes, sir.
Okay. So from here we can B and C. The distance between B and C is we can reach at 4.
Sir, it is not visible.
Wait. Is it visible?
No, sir.
No,
Wait.
sir.
No, sir.
No, sir.
Wait. I think connection was lost. Now?
Yes, sir.
Okay.
Yes, sir.
Okay. So here. Okay. Here. I have already, this one is I have taken or not? Okay. I will take the permanent level, this one. Okay. And from here we can reach that B and C and its distance is 4 and 2. It is 4 and at C it is 2. I can write okay. I think connection was okay. Here and there is no distance means there is no direct edge between A to D, A to E, A to D. So I will write infinite here. The distance between from A to any other point will be the infinite. Okay. Now we have to choose what is the minimum according to the step 1. We have to choose the minimum order level of J. Order level is this one, and order level of I plus distance. So distance we can add 0 plus 4, 0 plus 2. It means that it will be 4 and 2. So what is the minimum of these? So it will be 2. So I will write the permanent level of this. Okay. Now we are here at C. Okay. Now I have already taken this one, and it will be now 2. Now from C, what are the nearest point? From C it is B, it is D, and it is E. So it is B means if we go B is, I have already told you that D, 2 plus 1, it is 3. Okay, from here 2 already taken, 2 plus 8. So D, from D it will be 10. From this 2 it is 12. E. Okay, only 3 points. B, D, E. I can go B, D, E. So now we have, and there is no direct edge from C to D, so I will write infinite here. So again, I will choose the minimum of these 3. 1 from B, D, E. So what is the minimum? 3.
Sir, please explain once more.
सर आई क्या है सर?
I is the vertex from where we are start. Okay, and we are giving the permanent level of this.
सर जो लेफ्ट में आपने वर्टिसेस लिखे हुए हैं 1 2 3 4,
Yes.
वो कौन से वर्टिसेस को इंडिकेट कर रहा है वो भी थोड़ा बता
Actually these are the vertices. Here just I have denote A, B, C, D of these vertices, and it is also the vertices. It means 0 means first vertices, second vertices, third vertices, fourth, fifth, sixth. These are the same as A, B, C, D is given, but due to the due to avoid the ambiguity, just I have write numbers 0, 1, 2. There are 6 points here, and there are 6 vertices here. Okay.
ओके सर.
Okay. Now, in the before, I have seen that 3 to 10. Sorry, these number I have already taken the permanent levels A and C. Okay, so I will reach at C. From C, we the nearest point are B, D, and E, and total number of total distance from B, D, and will be 10. 12 and 3. I have choose the minimum of this one, this one, this one, and this one. The minimum is 3. So it means we reached at B. So what is the minimum? What is the nearest point of B? A I have already taken. Okay, I have already taken the permanent level A. At C I have already taken the permanent at C. And what is the only D is here. Okay, so I have taken the permanent level. This one is also, this one is also, this one is also 2. From B I can go D, and it will be value, because it is 3. 3 plus 5, it will be 8. Okay, and there is no distance from D to B and D to G, so I will write infinite. Now, so in this case, there was only 8 is the minimum, because these are the infinite. I have already taken the permanent level of A. I eight. 8 plus 2 will be 10. And here 8 plus 6 will be 8 plus 6 will be 14. Okay. Now what is the minimum of these two? E. Okay. 0 is also taken. 3 is also taken. 2 is also taken permanent level. 8 is also taken permanent level. And E is also taken permanent level. Okay. Where is we are E at E? We are here. Now, which is the nearest point of E is only D, because I have C, sorry, the nearest point of E are D, C, Z. But Z and E also I have taken the permanent levels. So I will add only 3. So it will be 3, 13. 10 plus 3, 13. So what is the root? So what is the path? Length path is 13. Length path is 13. And what is the root? Now A to
C.
C, sir.
A to C. Yes,
C to
you
B.
can see that. A to
C to B.
C, A to C, C to
B. B to D. And E to Z.
B, B to
D.
E, D to E,
E.
and E to Z. So this is the shortest path from A to Z. Yeah, between A to Z. Got it? Okay, I will take another a simple example. Okay. This one. 3, 4, 3, 4, 2. Okay, this is A, this is B, this is C, this is D. Okay, what is the simple path from A to C? Or not? A to D. I have to find the shortest path from A to D. I think it will be the clear. It will be just because A to D means A to D just 4. Because if you find this root, it will be 5. If you take this root, it will be more than 4. Okay. Now I replace here 1. Okay. Now we will use the algorithm. Here I will find from A to D. A, B, C, D. This is I 0, 1, 2, 3. Okay, we are start from here. So I will take only 0 always, and others I will take infinite. Okay, what are the nearest point? B, C, and D. Okay, B is 4. Sorry,
3.
from 3. This is 3 and C is 1 and it is 4. So we have to choose the minimum of these. It is 1. So I will take the permanent level of this. I have already taken the permanent level of A vertex. Okay, now we are here at C. Okay, and I can take 1 is as it here. Okay, now at C, what are the nearest point of C? D and B. D D and B. Okay. So we can take and also A, but I have taken the permanent level A already. Okay. So I will pass means its value is, if I can go through P, what will the value? 1 plus value of this is 4.
5.
So B, it will be 5. And from here it will be 3. Okay. So what is the minimum of these two?
3.
3. So I will take the permanent level of this, and I have taken this one. I have this one. This one is permanent level again, and this is the permanent level. So I think from this I reached at D. Okay. I reached at D. Got it? From A to D I have reached. So what is the minimum length? Hmm? Okay.
3 sir, A to C, C to D.
Length is 3. Okay. And path is A to C, C to D. Okay. Now, next topic is yes. Now we will move distance in the graph. A new topic, distance in the graph. Okay. Or we can say measurement in the graph. Okay. So these are means I have told you two algorithm. First one is the Filari algorithm. Second one is the Dijkstra algorithm. And also I have discussed two problems based on Hamiltonian and Euler circuit. These are CPP problem, Chinese postman problem, and traveling salesman's problem. Okay. Now we will move a new topic, that will be the distance in the graph. Okay. Now, okay, I have one problem, one question for you. From tomorrow we will start new topic. Have you got?
Yes,
Received,
sir.
sir.
Yes, sir.
Okay. Okay, tomorrow we will move new. Okay.
Thank you, sir.
Okay.
Thank you, sir.
Otherwise, I can take that tutorial also.